Here's the next one. I'm going to do another one for you. Same type of problem, calculating the pH of a weak acid with a strong base on ALEKS. So this means you're going to have 3 examples of how to do this. So first we're going to write a balanced equation, HC6H5CO2 plus OH minus. Remember in the last video I said the NaOH is just Na plus and OH minus, and it's easier to just write the OH minus because the Na is just a spectator. And our products are going to be C6H5CO2 minus. I'm just taking that hydrogen off the molecule, and H2O. And we're going to make an ice table, and this ice table has to be in moles, not in molarity. So our first job is to figure out how many moles of benzoic acid do we have. We have 0.3800 moles per liter, that's the molarity, times the volume, 0.2441 liters. 0.38 times 0.2441 is 0.9276 moles. And for hydroxide, we have 0.73 molar solution, 41.89 milliliters. 0.73 moles per liter times 0.04189 liters. 0.73 times 0.04189, that is 0.03058. And initially we have no product. With the strong base, because we have a strong base, that means this is a complete reaction. So we are looking at our 2 reactants. Which one do we have the least of? We have the least of the hydroxide, the smallest number. That is going to control how much this reaction goes. It's going to control our change. The X minus X plus X. And we can calculate how many moles we have at the end of this reaction. For the benzoic acid, HC6H5CO2, we have 0.09276 minus the change, 0.03058. That leaves us with 0.06218 moles. We have no hydroxide, and we have 0.03058 moles of benzoate, C6H5CO2. So now we're ready to calculate the pH. On the worksheet, we did a problem like this on the worksheet. So when we get to this point in this type of calculation, we've got 2 possibilities. If we have hydroxide present, then we use it to calculate the pH, and that's what we had in the last ALEKS problem that I did for you. That's how it went. When we don't have hydroxide present, we use the acid and the conjugate base and Henderson-Hasselbalch to calculate the pH. pH equals pKa plus the log of the concentration of the base over the concentration of the acid. The pKa is, up here in the problem, kind of hard to see it because I've written over the top of it. The pKa is 4.2. 4.2 plus the log of the concentration of the base. Which one is the base? We're looking at this guy versus this guy. The acid has the most hydrogen, the base has the least hydrogen, 0.03058 over the acid, 0.06218. Now you might be saying, oh my gosh, wait up, slow down. Those are moles. This is supposed to be molarity. You've got to do a molarity calculation there. You actually kind of don't. So this is me being lazy. I'm going to do it like this, and then I'm going to do it the quote-unquote right way. And we'll see that it's not always necessary. So right now I'm working out the math on the Henderson-Hasselbalch equation, and I get 3.89. So let's do this then the right way. Let's use molarity instead of the moles. To calculate the molarity, we're going to take the number of moles and we're going to divide it by the total volume. The total volume, where do I have room to write this? The total volume is, I'll do it over here, total volume 244.1 milliliters plus 41.89 milliliters. 244.1 plus 41.89. That is 285.99 or 0.28599. So our base molarity is 0.03058 divided by 0.28599, 0.1069. And our acid concentration is going to be the moles divided by that same total volume, 0.28599, 0.06218 divided by 0.28599. That is 0.2174. Let's see what we get. Right now I'm just using my calculator to do the Henderson-Hasselbalch math again. 3.89. What? How did that work? It's like some kind of magic. I almost spelled magic wrong. Notice that the way that this works, so if we go back up to this one that I did when I was being lazy, I just used the moles here. What I didn't do is divide by volume, which is exactly the same for both the base and the acid. In this case, because they both have the exact same volume, that number actually mathematically cancels out, so you kind of don't need to use it. If that's confusing to you, just always convert it into concentration. So this pH is 3.89, and I'm going to put this into ALEKS and we'll see how I did. Thank goodness.